In my previous video, I talked about Wake-on-Lan in general, focused on the magic packet and how it works. So in this video, let's discuss Wake-on-Lan on Windows in more details. Here I show you the terms related to sleep in two different columns. The sleep mode is the words used by people in regular conversation, but in fact, in real-world implementation in PC, it can be mapped to totally different things. For working, hibernate and power off is very straightforward, but the complexity is in the definitions of sleep. So there are multiple sleep states defined in the power management standard ACPI. In the old days, S1, S2, S3 are the only supported ones. So normally when people talk about sleep, in most cases, people were really referring to S3, which is suspend to RAM. Later, especially with recent Windows upgrade, Microsoft has been pushing the S0 low power idle mode very hard. From hardware perspective, many PCs you purchase may only come with one single sleep state support, which is S0 low power idle. This state has multiple names. In Microsoft's document, it's referred as modern standby. In Linux, you will see S0IX, but basically it's the same thing. Because in my previous video, I already discussed the classic mode in details about S3. So in this video, I'm going to focus on comparing S3 and the modern standby and show you whether the Wake-on-Lan, the magic packet technology, still works. Okay, let's get started. This is my lab environment. I use unified switches and the router is pfSense. I'm going to try both Wake-on-Lan on wireless LAN, the Wi-Fi mode. And I'm going to use pfSense to send the magic packet, but you can use any free tool in whatever operating systems you want. I use two different PC hardwares. One is old one, which only support S3 for sleep mode, and the other one is relatively new one and it only support S0 low power idle mode. So let's see how Wake-on-Lan behaves differently in the two different hardwares. By the way, they have the same version of Windows 11 Pro operating system. As I mentioned, I'm going to test both LAN and wireless LAN mode. For your convenience, I marked their corresponding IP addresses and MAC addresses. The magic packet needs MAC addresses to work. On the screen, you see multiple windows. This is pfSense. I'm going to use it to send the magic packet, try to wake the Windows machine from sleep mode. And in the lower part of the screen, you can see two Windows sessions. The left one is the one with legacy standby support. The right one is newer. It has the modern standby support. Before we do anything, let's check the supported sleep state. The command is powerconfig with the parameter available sleep states. So as you can see, the left one, it only supports S3, which is the legacy standby, the classic S3 suspend to RAM. And the right part only supports S0 low power idle, or the so-called modern standby. It doesn't support S3. So these two Windows machines are dramatically different when it comes to which sleep state it supports. Let's see how they behave differently when it comes to Wake-on-Lan. In my previous video, I already showed you the details about the left side machine, which only supports S3, the legacy standby. It can perfectly support Wake-on-Lan through magic packet in all the modes, S3, S4, S5. So in this video, I won't show you that information again. If you are interested, check my previous video. So let's focus on the right side machine. In the two Windows sessions, let me run the same command, power CFG. The parameter is device query, wake programmable. Basically, I want to know what devices are capable of waking up the computer. I'm not talking about whether they are enabled to do that. I'm just curious about which devices have the capability. In the left side, I only see 4 devices. In the right side, I see a little bit more, but if you check the left side result for the Windows which support legacy standby, I can find my Wi-Fi card, Ethernet network card. But if I check the right side, I don't see my network interface cards at all. Doesn't matter whether it's Ethernet or Wi-Fi. So to furtherly understand why, let me go to the device management for each Windows. If I double click, let's say, the Ethernet network interface card, you can see this tab is called power management. And if I go there, I can see, yes, it's checked, allow the computer to wake up, and I only allow magic packet, right? That's how Wake-on-Lan is supposed to work. No problem at all. But if you check the right side, the Ethernet network interface card, I don't see that tab. So I have no way to enable it. That's why in the Wake programmable result, I don't see the interface card. Let me furtherly check in each system whether network interface cards, they are enabled to wake up the Windows. Let me run the same command, but with a slightly different parameter. The command is power config device query wake armed. Armed means it's set, it's enabled to wake up the computer. Let me run them. In the left side, no surprise, both the Wi-Fi card and the interface cards, they are enabled. And in the right side, they are not even capable to do that. Of course, they are not enabled. Just based on this, theoretically, for the right side Windows, the one which supports modern standby, if I send a magic packet, it shouldn't wake up the computer, right? But let me try it. Now let me ping the IP address of the right side Windows. In the diagram, I already noted down the IP address for RJ45 port and Wi-Fi. So let me ping it. Of course, it's pingable at this moment. Then let me put the Windows in sleep mode. As you can see, even though I clicked sleep, there's no response in the remote desktop. That's one change in the modern standby mode. By default, the remote desktop will disable the sleep. So to really put it to sleep mode, I need to close the remote desktop. As you can see, in the ping session, it is still pingable. That's another change which I really don't like about the modern standby is Windows operating system thinks it's very smart, so it will decide whether or when to put the system really to sleep. And now you can see sometimes the ping will fail, sometimes it will resume. It's completely controlled by the operating system. So let me give it some time so that I have very stable ping failures. Then let me try to send a magic packet. I believe now is the time. I can see the LED light for my PC is flashing. That means it is really in sleep mode. From pfSense, let me send a magic packet. Okay, as you can see, immediately it wake up the Windows. And I can tell from the LED light, it's running, so it's not sleeping anymore. I just successfully wake up the Windows from sleep mode, even though theoretically it shouldn't. Let's try wake on wireless LAN. So I already physically unplugged the Ethernet cable. It's only connected through Wi-Fi. In the ping session, let me ping the IP address for the Wi-Fi. Okay, it's pingable. Let me put it to sleep mode, the exact operation I did previously for Wake-on-Lan. And then close the remote desktop, give it some time. Okay, after a while, as you can see, I see ping failures already, and it's come and go. Give it some time till it's stabilized. Okay, it seems it's very stable in sleep mode. Then let me send a magic packet to the MAC address of the Wi-Fi card. See, it does have some effect because it did wake up the system a little bit, but apparently Windows decided to continue to sleep. I see different behaviors when it comes to Magic Packet, LAN or wireless LAN. Everything about modern standby is mysterious. Different people will see different behaviors in different hardwares. So it's super hard to explain why. But this is my observation. Let's spend more time on the hibernate and power off mode testing. So in the left side ping session, let me ping the IP address of the Windows. Then let me put the Windows to hibernate. Okay, hibernate is successful, so the ping failed, right? Then let me try to wake it up using Magic Packet. Nope, it didn't work. Try again. Nope, simply didn't work. Then, of course, I don't think Wake on wireless LAN will work, but let me still try it. Of course, it doesn't work. Okay, both failed. And let me try the power off mode. Similarly, ping the IP address and then power the Windows off. Okay, it's powered off. Then in pfSense, let me send a magic packet through Ethernet. Okay, you know what? I can tell from the LED light of the PC, it is powering on. I believe you will see the result shortly from the ping session. It's very weird result. So let me summarize. From the operating system level, both the Wi-Fi card and the Ethernet network interface cards, they are not enabled to support Wake-on-Lan, but both work in sleep mode, and both don't work in hibernate mode. And the Wake-on-Lan works in power off mode. Of course, for the Wi-Fi card, I don't want to waste my time on testing whether it works on power off mode. Of course, it doesn't work because there's no power to the card, right? But the fact that the Wake-on-Lan works in sleep mode and in power off mode, it is weird. Now let's see whether we can upgrade the driver to enable the setting for the network interface cards. Okay, I just upgraded the two drivers for Wi-Fi card. Nothing's changed. I still don't see the power management tab, which is disappointing. For the network interface card, finally I see this tab. It's a good sign. It seems there's nothing which can prevent the Wake-on-Lan from working, right? But let's see whether that's the case. Remember, before we upgrade the drivers, when we run the command power config device query wake programmable, we didn't see the network interface card, right? But this time, because of the change of the driver, finally I see this card. And then, as you can see, I already enable it. If I run the other command to see wake armed, I also see this network interface card. Everything looks good so far, but let's see whether it really resolves our problem. In the left side, let me ping the IP address of the Windows. Then let me put it to sleep mode. Give it some time. I have waited for more than a minute, but the ping is still successful. However, I can tell from the LED light of the PC, it is flashing, which means the operating system does consider it's in sleep mode. I already observed one difference after the driver upgrade, which is even now the operating system is in sleep mode, the ping is still active. So you can still do something when it comes to network. But anyway, because the LED light is flashing, let me see now if I send a magic packet, whether it can cancel the sleep. No, nothing happened. No, the LED light is still flashing. So it is a bummer. Very disappointing. After upgrading the drivers, the situation is even worse. I even cannot wake up the Windows from sleep mode anymore. The main point I want to show you is for modern standby, the behavior you observe in your particular hardware and in your particular BIOS setting, in your particular network interface card configuration will be strange. Many times it's very hard to explain. It's a very messy situation. I really miss the good old days when every PC support the S3, the legacy standby. Okay, this is the end of the video. Thanks for watching.